Microsoft has quietly dropped one of the most disruptive releases in AI infrastructure history. BitNet is an open-source inference framework that runs a 100 billion parameter language model on a single consumer CPU. No GPU, no cloud, no specialized hardware. This isn't a demo or a research paper. It's a production-ready shift in how we think about deploying AI at scale. Traditional large language models store their weights as 32-bit or 16-bit floating point numbers, rich, precise, and extremely memory-hungry. BitNet replaces all of that with ternary values, -1, 0, or +1. That's literally 1.58 bits of information per weight. The genius here is that your CPU was already built to handle integer arithmetic at high speed. So suddenly the processor in your laptop becomes a legitimate AI accelerator without any modification. The benchmarks tell a story that would have seemed impossible 2 years ago. BitNet delivers 5 to 7 tokens per second on a 100 billion parameter model using only a CPU, up to 6 times faster than llama.cpp on x86 architecture. Energy consumption drops by 82% compared to GPU inference, and memory footprint shrinks by 16 to 32 times versus full precision models. Perhaps most critically, accuracy barely moves. These aren't lab conditions trade-offs. These are real workload comparisons. If you've ever designed an AI inference pipeline, you know the GPU assumption is baked into every single decision you make. Which cloud instance to spin up, which accelerator to provision, how to batch requests to maximize utilization, how to manage costs as you scale. These aren't just technical choices, they're business constraints that shape product roadmaps. BitNet doesn't shave costs at the edges. It questions whether the GPU-first premise was ever the only path forward. The deployment implications ripple outward in every direction. Imagine capable AI running entirely on edge devices without any network dependency. Think about air-gapped government or enterprise environments that legally cannot touch the cloud. They can now run serious models locally. Consider developers in regions where cloud compute costs are prohibitive barriers to entry, or embedded systems and IoT devices that could run real language models. And for consumers, on-device AI finally delivers genuine privacy without sacrificing model capability for a toy-sized alternative. The criticism will come, and some of it is fair. Ternary quantization does degrade performance on certain precision-sensitive tasks. Complex mathematical reasoning, highly specialized domain knowledge, and tasks that rely on the fine-grained numerical distinctions that 16-bit weights preserve. The honest framing is that BitNet is not a universal replacement for full precision inference. But for the vast majority of general-purpose language workloads, a 100 billion parameter model running competitively on your laptop, CPU has crossed the threshold from research curiosity to legitimate production consideration. One detail that practitioners are particularly excited about is the ARM architecture speedup. Apple Silicon MacBooks are already efficient inference machines, but BitNet's ARM-optimized kernels take that further in ways that genuinely surprise people when they first run benchmarks. If you work anywhere near inference pipelines, spinning up the GitHub repo on a MacBook takes about an hour and delivers a visceral demonstration of where this technology stands today. The gap between what you expect and what you actually see is the moment this stops being theoretical. Stepping back, what Microsoft has done by open-sourcing BitNet is hand the community a genuine architectural alternative that was previously unavailable. The GPU monopoly on serious AI inference isn't broken overnight. NVIDIA's ecosystem, tooling, and training advantages are enormous and durable. But inference is where most of the real-world compute cost lives, and BitNet just demonstrated that this layer of the stack is now contestable. The developers, startups, and enterprises who explore this early will have a meaningful head start on the cost and capability curves that follow.